So this is a demo for P, the fractal ellipse problem. Here's the initial display. You'll actually get this with the starter code or something very close to it, although there are lots of sliders and buttons and things. They're not actually tied to anything in the starter code, or they're tied to empty methods in a class you have to implement. So this is a pseudo-fractal problem. Here we have so a fractal problem, or fractal visualization is one in which each component is in turn represented in similar components. So in this fractal ellipse problem, the parent component is a circle right now, but we can change that to an ellipse if we want, and we can change the initial size of it. And the children of the initial root ellipse are, there'll be 4 children in this case because of the child count there. When we do a recursion depth of 1, it means there'll be 4 children drawn at equal points along with their centers along the circumference of the initial circle. So here we have 4 children of the magenta ellipse are blue ellipses, again because I've made them circles, but if we change the height and width ratio, then all of the ellipses from the parent to the children will become ellipses instead of circles. If we change the initial size, then they change appropriately. The child size ratio is a ratio of the size of the children to their parent, so this in this case is 50%. As we then recurse, then each of the children at recursion depth 2 will create 4 children of theirs at a different color so that they can show up. Again, as we change the child size ratio, they will change at all levels. We can change the overall ellipsoidal instead of circle. And the initial overall size will just change the initial overall image. There's also, with these 4 children, the default is that they will be drawn at 0 degrees off of the horizontal, 90, 180, and 270. We can change the offset of those, which changes, let me go back to a simpler case here. It changes not only angle, but it moves it off the circumference. So we can make these actually spiral into the center by changing the child offset. And that makes some interesting images here as we do this. And now we can go up to a depth of 4, a depth of 5, a depth of 6. That's the maximum depth. All of a sudden, we start getting different patterns that show up, and as we change our various parameters, we get some interesting behavior here. Changing the child size ratio gives us some interesting visual things. There's for purposes of debugging especially, sometimes it's better to turn off the fill and show just the boundary so you can see better what's going on inside. You can also, as the default, these are all drawn as opaque. The interior is opaque, but we can make it semi-transparent and add an alpha blending to it so that you can see through, which gives, again, some interesting visual patterns that are kind of fun. Finally, we can go back. They should be able to reset all the parameters here to the defaults. So here, oops, we have to have at least a recursion of 1. So here we have a child count of 1. which means as we go up, just one child is added. That's actually a good place to start in terms of it's a simple computation. Make sure you get it right. If we add 2 children, then then you get the growth only along the horizontal. If you add 3, then you get some nice patterns here in terms of making things look like triangles in effect because you're adding children. 4 is the default, 5, 6. So in each of these cases, there are that many children scattered around the peripheral of the parent. So that's your task, and have at it. And again, the reset lets you restore all of the initial parameters to defaults, just to make sure, especially as you're debugging things, you can get off track and can't quite figure out what's going on. Okay.